Hello again, Kevin Culp here from Supermicro. Today we're going to look at Supermicro's blade technology. As mentioned in previous videos, Super Blades are yet another one of Supermicro's golden SKUs. With its broad range of workload applications, it is an excellent candidate for data center use cases. Within the last couple of years, we have been working closely with our customers making significant improvements in blade lifecycle management within SCC. Our focus was to provide our blade customers management oversight at scale across multiple racks leveraging the features of PodView. With the new CMM6 modular design for both 6U and 8U J2 enclosures, we were able to pull Redfish endpoints directly from the CMM, providing administrators necessary lifecycle management requirements. It is important to step back a few moments and understand what the role is for the CMM. The CMM is a web-based management utility for Supermicro's blade enclosures, where administrators can get more granular management functionality within the enclosure itself. The CMM interface can be defined with an IP static address or obtain a DHCP management IP address from a scope. When logged into the management plane, several features can be exposed, such as IP assignment of blades and interconnect switches, power capping, power management, firmware management, BMC management of blades, and other functionality as well. So what is SCC's value proposition for the blades? In short, the following points can be presented. Management scaling across many racks, top-of-rack provisioning of interconnect switches, OS deployment at scale, blade asset management, blade enclosure visualization within racks and groups of racks, firmware management at scale, power management at scale. SCC brings a different look and feel to a Supermicro blade. Our approach was to loosely couple SCC's management functionality, continuing to allow CMM to provide administrators management functionality for its blade enclosure control. So how do we differ from our competitors like HPE? HPE's Synergy Frame Fabric integrates its HP management plane with software called OneView. With this tightly coupled approach, data center administrators can be vulnerable to interruptions in traffic because Synergy relies on its OneView software to manipulate profiles and make changes to its interconnect modules within the Synergy ecosystem. It relies on a clumsy image streamer appliance to be in complete control of its OS deployments, locking administrators into HP's proprietary ecosystem. With SCC loosely coupled integration of blades, administrators have flexibility for their OS deployments without relying on an image streamer appliance to perform these tasks. Let's see how SCC's powerful management suite can improve blade lifecycle management. Okay, to save time today, we've logged into our dashboard. So we logged in as global admin. As you can see, we've been directed to the dashboard. And so now we're going to go ahead and perform lifecycle management for blades. So day 0, day 1, and day 2 operation for a blade. So what's the first thing we're going to do is we're going to direct and navigate to what we call our pod view, which is to start our day 0 lifecycle management. So the first thing we want to do is really go ahead and create a rack. And then what we can do so is associate that blade to that rack. So if we click here to the right under edit mode, it will start basically allowing us to create our day 0 activity. So first thing we want to do is create a rack. So we'll go ahead and add a rack. You can also add a group, which is a number of racks that are associated with a group, but in this case, we're just going to add a single rack itself. So the first thing it asks for is rack location. So we'll go ahead at this point and we'll call it blade rack just to give it a description. And then also we'll skip over into rack description. We'll say it's in building 6. And you have the option here to choose a 12, 22, 42, 52, or 58. We'll go ahead and choose a 42. And also, we automatically go ahead and associate a color, a default color, to the rack when it gets created. So we'll leave it as blue to create it. We'll save it. And then that shows us we've made success here to go ahead and create a rack. And so let's go to the left-hand side and see if it is there. We'll pull up the blade rack. We'll show the front and rear view. You notice here it sequenced the rack slot units from 1 through 42. There's nothing associated with any of the racks so far. So now we need to associate the system or the blade enclosure to the rack. So to do so, the first thing we're going to do is perform a discovery to go ahead and look for this blade enclosure. As I mentioned in previous videos, there are 2 ways to discover a device: through setting up an IP range, and then also through what we call SSDP. Now, SSDP is what we refer to as Universal Plug and Play, Redfish's DMTF standard. All of our BMCs default to this operation. So any of our friends across the aisle may not implement SSDP on their BMCs, such as ILO and iDRAC. You can go ahead and issue the range command, which essentially provide you a ping spray, or you could manually add it in the manual tab itself for the IP address. So we're going to choose the IP range. So the IP address we're looking for is the IP address of the CMM. Because it's using a 200 addressing scheme subnet, we have a DHCP server on our back end that goes ahead and provides leases and scopes to our servers within our data center. So we're going to plug in 200.200.1.246, and then we're going to only look for 246. If we had a group or range of IP addresses, this would be the starting range and the ending range. So we'll hit submit here, and at this point in time, it'll start cooking and finding and discovering this particular enclosure. While we're waiting for this to complete, we have a northbound API that you can communicate to associate a number of servers to a group of racks, or creating groups of racks, or creating groups of pods, or deploying multiple operating systems to a server. All of this is available to you on our northbound API. We provide an SDK of both Python and Ansible scripting that you can go ahead and communicate with our northbound API. We wouldn't expect you to create 1,000 racks within the GUI and go through each one and associate many systems, especially in our scalability release where we support thousands of servers. It just would not be a good use of your time. So the first thing we want to do is look at what was discovered. It is definitely a 6U enclosure. It's a J2 enclosure. The J2 is for allowing for double wide servers to go into the enclosure itself. So this is the new generation of both 6U and 8U that is available within Supermicro to order. It's getting quite a bit of popularity in some of the orders I'm seeing coming in. for folks to take this blade technology and use it in a high performance compute vertical or in a data center vertical. So first thing is we provide the serial number, SKU, BMC IP address. Each of those IP addresses are the blades themselves. And then we also have 3 switches that are plugged into this enclosure that are referred to as interconnect switches. And how do the blades interconnect to an upstream connection like a Tor switch? Is they really have what we refer to as downlink ports. So all the Ethernet traces on the mid plane are connected into what we're referred to as NICs that are inside these blades. They connect to those Ethernet traces or Ethernet connections on the interconnect switch. And then packets are forwarded out into the uplink ports of the interconnect blade switch. And then, of course, they would be connected to some type of top-of-rack switch provisioning switch that you can go ahead and get connected into your network. So let's double-click it. And when we double-click it, we are entered into what we're referred to as the drawer configuration wizard or configurator wizard. And there's a couple of fields that you need to plug in here. If we were associating this particular enclosure to a group, we would use the drop down to associate it. But in our case, we only created one rack. We called it blade rack. Of course, we should see it in the rack list, and we do. We're going to select it. It's a 42U rack size enclosure like we created. Some information that we go ahead and collect or harvest from the CMM itself. And then also let's choose, say, rack slot unit 8. Really doesn't matter which one you select, because in this case it's an empty rack, so there's lots of space to utilize, so we just chose 8 there. We're going to click on the next icon to move us through the wizard configuration. If we click here, it's giving us the ability to exclude that blade from the enclosure. So in some cases, we may have customers who want to exclude certain blades and associate them with other particular racks that were added itself. So in this case, because it's a full enclosure, there's no way that we can associate this blade to another rack. So we'll keep it as included. Some of good information here is showing you that the license has been activated for DMCS, which is our BMC Redfish license associated with the blade environment. An IP address which has been scoped, 200 addresses that have been scoped through our DHCP server, MAC address, the slot location that we show you here. So A3 is in slot 3, A1 is in slot 1, and A4 is in slot 4. So we show you slot identification information that was derived from the CMM through our Redfish endpoint query. So we have an agent that goes out and communicates to the CMM. The CMM is definitely the source of truth here. And we have admin of username and password. So next, we've also discovered switches that are inside this enclosure, these interconnect switches. We have an option to use either it as a compute switch or storage switch. In our case, we're going to use all of them as compute for an example here. And again, it's providing you a slot identification A1, A2, B1. This is used for you to provide redundancy of switches. Perhaps you're building a Linux kernel and you configured some type of bonding associated with the NICs, and you want to provide redundancy of each of these switches so that your applications are still running without the essentially a interruption of service that perhaps a NIC or a switch was to be compromised. So then we're going to go ahead and click next. Some information here, summary information provided, asking you to confirm the detail here. We're going to say finish here, and at that point in time, once we say finish, it will add it to the enclosure. So you could see here on the left hand side, we go ahead and use slot number 8. That's what we chose to associate this blade enclosure. We're showing both the front and rear view of the blade enclosure. Let's scroll up a little bit and show you the IP addresses that are associated with this enclosure that have been added to the drawer configuration. And if we click on the tree view here and uncollapse it, we show slot number 8 or drawer location 8 has been utilized. And at this point, we see the identification of appliances that were added, 3 which are blades and 3 which are switches. And if we click on the 8 here, at this point, we should see in here information associated with both the switch and also the CMM. So it's going to take a couple of minutes because we're still going out and collecting PSME agent information from the BMC itself. So let's do a little bit of discovery of what else we can look at associated with this blade. Here we're seeing information associated with the blade rack itself, showing you good standing of each one of the blades as far as the compute is concerned. Let's click here on 8 and see if it's ready to show us the information. It is. So it's completed the information associated with the enclosure. We show some very, very useful information here for a blade administrator using a chassis management module, which is a CMM. So we provide you a visual of what it looks like. And then, of course, we provide you slot ID information here too as well, showing you specifically information about the CMM. And then if you had a second CMM for redundancy purposes, it would be shown in the second location slot for CMM. In our case, we don't have a second CMM, so we're just showing you basically blank information there. So let's swing back to the pod view again for a moment and see if we can look at detailed information about the blade enclosure itself. So by clicking on number 8 here again, we now see the CMM showing you the slot in which it is, the IP address. If you click here, you can launch a new window and get connected into the CMM. But for this purpose, I want not to do that because we want to save some time on this video clip. I feel, dragging out these videos sometimes can not be useful for you because everybody's time is important to them. We provide you the firmware version itself, the CMM module as well. It's a CMM 6, which is a 6 modular design. that Supermicro has just released. And then if we click on the switch icon here, we provide both the switch information, firmware versions, and the switch module. You can click here again and get directly into the web-based interface of the switch. And then we show you drawer information that was collected from the agent that's running to collect information from the CMM, and some of this data was input that we added. So in a nutshell, that's the blade itself and how it has been represented within the rack. So let's move back to the compute itself, because now this blade has been officially registered within SuperCloud Composer. We see information about the blade. So let's go and look at each of the blades themselves. So we'll start again up at the 8 level, show you the blades that are associated with the CMM. So if you had a number of blade enclosures scattered across multiple racks, we would basically show you the CMM that's associated with each of these blades, right? So that's something we show at scale, right? When you have multiple enclosures across racks, how do you determine which particular blade is associated with which rack and enclosure? So we provide that information to you at scale to give you an oversight of being able to support your blade lifecycle management. So let's click on the slot number 1. So slot number 1 is a blade. We provide the front view and the top view. All of your physical asset collateral information is here. BMC version, BIOS version. The form factor is the 6U enclosure. So it is a 6U type enclosure for the blade. Serial number, the motherboard type, product family is blade family, BMC IP address, and so on and so forth. Health roll-up, power state, CPU module, everything is there like you would normally see in any one of our Supermicro product SKUs. So SCC covers a number of product SKUs across the entire product suite of Supermicro. All right, so on the top right here, we provide all the lifecycle management requirements for this blade itself. So we're minimizing the number of clicks it takes to get into the BMC of the blade to provide any collateral or asset information you're looking for, or even being able to perform tasks within the BMC, right? So we want to provide all those functionality inside SuperCloud Composer without having to go into the BMC. To the top here, we have processor information. So we have a carousel view. If you put your mouse in the window of the carousel view, everything will be stopped scrolling. And if you remove it out of the carousel view window, we would start scrolling again after 5 seconds. To the left-hand corner here, we have what we refer to as the navigation window. And the navigation window opens up a number of different things we can look at associated with this blade, such as the type of processor that's here inside this blade. So we have what we refer to as a 2 socket blade, which has essentially 8 core for each. It's a 16 core in total. We're utilizing a Gold Series processor, which is clocking at 3.60 gigahertz. Will expose in the next release the serial number of the blades themselves. This would be the CPU itself serial number. We're going to associate the serial number for each of processors that are in the entire product suite of Supermicro servers. A very good asset tracking mechanism to be able to show the serial number, and we can take that information later and export it into a CSV file that you can perform some type of asset tracking through some type of spreadsheet that you have. So we will expose all of these attributes for each server into a common delimited file, CSV file, where you can take this information and pivot or build Excel spreadsheets so that you can keep track of your inventory. Total core, state, health, all available to you as well. You notice here that we also provide local GPU, attached GPU, and attached FPGA. So the double wide type of blades within this chassis support a number of GPUs. Certainly we can collect performance metrics associated with them using, typically it's an A40 or L40 GPU accelerator. And this would be exposed here to show you that there would be one local GPU server, two, depending on how many that you have inside the blade. But in this case, we have no GPUs that were found inside this blade. Memory. So memory is very small for the memory footprint. We only have 32 here. And of course, because it's a dual socketed type of blade, we can look at memory in both NUMA regions. And we provide you with the slot ID, part number, size, device type. So all of this information is provided to you for asset tracking purposes. And then I won't go through the rest of them because a lot of this will be duplicate, because we've already did a previous video on collection of local storage, remote, iSCSI storage. All of these that we had talked to you about is also available within any blade itself. So I want to draw your attention now to really looking at the networking piece. So let's go look at these interconnect switches and see what we have in our data center. So I mentioned in previous videos that we support third-party switches. In this case, we have an Arista switch that we currently support, all the Arista product line, 400G, various different entities of Arista we support. Why do we support Arista? Is because it has a RESTful API that we can communicate with, as well as all of our Supermicro switches have RESTful API that allows us to communicate and render the screens quickly instead of having to scrape the data, and could cause the rendering of the screens to be somewhat sluggish, which is not a good end user experience. And then you see here we also have the Sonic switch, which is the 400G switch that we have supported as well. So we have three blade switches inside here. They all have IP addresses. We show the serial number, and we also show the firmware version. And then we also can perform lifecycle management on the switch itself too as well. So let's go ahead and click on the 25G200 switch itself. When we click there, let's click the detail here and see who our upstream switches that we're connected to, or we refer to that as our LLDP neighbor. So we have detailed information about the switch, such as the system model, a firmware version, so on and so forth. All of this information is vital information for a network administrator. And then we also have the LLDP neighbor. We have no data there to indicate that we have any uplink connections connected. So we don't have anything connected into our upstream switch. So therefore, we will report nothing is connected. If we had an uplink connection into our blade, then we would report who our LLDP neighbor is, or who is upstream to us that we can communicate with. Okay, so let's look at this 25G switch itself. And when we look at the 25G switch, we see information about the 25G. So if we click here, we have another way of looking at this information. So in this case, we can look at A2, and A2 brings up what the switch basically looks like. At this point, we have switch uptime itself. And we have other useful information that we collect. We can perform, as I mentioned before, lifecycle management of this switch. We have MAC address information. There's some VLANs that we've created here for testing purposes. By default, a switch comes with VLAN 1 as configured, which is the native VLAN. And then we go ahead and configure VLANs associated with this server. So because we have no connections that are connected to any of these VLANs or an upstream switch, the MAC address table is not populated. All right, so let's look at VLAN list. So we've created some VLAN names and VLAN IDs for testing purposes. If you wanted to create a VLAN, you simply would provide a VLAN between 1 through 4069 and then give it a VLAN name. So let's look at ports. So we have what were referred to as physical ports and logical ports. Logical ports are grouping ports together to get additional bandwidth and redundancy. The industry calls that a lag. And then we have the physical type ports that we could look at. So when we look at the physical ports, we identify a color code to each one of these physical ports. Color coding is uplink port is purple, system is blue, light blue is storage, and then if we had a PCIe switch APA connected, then it would be yellow. But because this is a blade enclosure, we don't have any PCIe switches connected. That would be a rack-mounted server that would be able to connect to a PCIe switch with a Fabrics card that's connected inside that server. So in this case, we would never see any PCIe switches connected to this blade enclosure. We also provide a list of port names. Those port names, which are FX1, 2, 3, and so on and so forth, are what were referred to as 25G NIC connections. So those are the downlink ports represented within the enclosure itself for the blades that are interconnected to the downlink ports of the interconnect switch. We have an MTU size that we have set. It looks like it's set for jumbo frames of 9,000 MTU size. We have VLAN mode, can either be configured as an access port or trunk. We see here that FX7 is associated with a trunk, with the native VLAN of 22 presented to the port, and then we're actually allowing VLANs 1 and 22, and it's showing flow control as off, and then also administrator status is up itself. So that is associated with the physical ports themselves. We have also other pages you can go down and scroll down to look at other particular ports that you want to take a look at, and so on and so forth, right? So administrative status is showing up, and so on and so forth. Okay, so logical, we're not going to get into any logical port identification. You can create it through here for time purposes. Here we want to keep it short with this presentation. And then I want to draw your attention to the network provisioning piece of blade switches. Instead of connecting in and issuing multiple CLI commands, you have the ability to go into the provisioning agent and be able to make those changes within SuperCloud Composer. So let's just quickly go through here and see what we have offered here. So if you click the icon in the top right, which is the icon to show you like a Cat5 or UTP connector, it immediately cautions you to say that you're entering into configuration mode, that some of your VLAN configurations could be altered. So we say OK there. And if you wanted to create additional VLANs, you could do so. And then next, I can literally, with the drag of my mouse, can change access ports immediately to trunk ports and then associate those VLANs to those trunk ports. Very powerful within our provisioning agent to allow you to do so. Dangerous, obviously here, if you had an environment here where these were access ports and you did not make the appropriate changes within the operating system to support that, you could have reachability problems. But if you're provisioning switches for the first time, to be able to configure these trunk ports would require you to execute multiple commands and associate those VLANs to those ports itself. And then we can go to next here, and then from next we can continue on and associate your VLAN IDs to each of those ports. We sort of provide you a matrix here or table that you can quickly click the radio dial and then allow you to continue on and provision and push out the configuration to the switch. So that's about it for lifecycle management of a blade. Thank you for joining. My name is Kevin Culp. Looking forward to doing some more demos here in the future for you and showing you lifecycle management and the versatility and flexibility of SuperCloud Composer. Thanks for joining. We'll see you next time.